look at the opposite. Now, what if we try to expand this? Okay, so what we're going to do is we're going to take it from one logarithm to multiple logarithms. Well, we're taking the log base 5 of 7x. Since we have two terms right here, we're going to actually end up with two logarithms. So we're going to have a log base 5 of just the 7. And then because this is a product, I can expand it. It will be addition, and it's log base 5 of x. And there's no exponent, so I'm actually finished expanding that, and there's my final answer. We just had to use the product rule. Okay, how about this one? Now this one's a little bit different. We have a quotient. We have division, so we're going to have to expand that, plus we have two terms on top. So don't forget, just because this is a constant, it also gets its own logarithm. So we're going to take log of 3x minus log of y. Now, often people will stop here thinking they've expanded all the way, but look, we have a product here. So when you have a product, you have to, remember, we're going to expand that into two logs. So log of 3 plus log of x minus log y. And that's how we would expand that one, okay? And that was using the quotient rule and the product rule. Now we can actually use logarithms and use substitution to evaluate them, okay? So what we're going to do is we're going to look at these logs, and we're going to have to rewrite them in expanded form and then evaluate. It's actually kind of a cool concept. Okay, so we've got log base 3 of 6/5. Well, right now we'd have no idea what that value is without a calculator, but we're given values from the calculator for both the log base 3 of 5 and the log base 3 of 6. So what we want to do is we want to expand this. So we're going to take the log base 3 of 6, and we've got a quotient rule, so we're going to subtract the log base 3 of 5. Okay, at this point we can use substitution. We know the log base 3 of 6 is this, 1.613. So 31 minus the log base 3 of 5, which is 1.465. So now all we do is literally subtract these. So let's see, that's 11 minus 5 is 6. We borrowed from here, so that's 12 minus 6 is 6. We borrowed from here, and that's 5 now. 5 minus 3, 1, so it's 0.166, and there's that value. Okay, so what happens here for the second one is log base 3 of 30. Well, how can I rewrite 30 knowing only 5 and 6? Well, that's just the product rule. So I can write this as log base 3 of 5 plus, because I can rewrite this as 5 times 6, sorry. And now I'm going to expand it and do log base 3 of 6. Now use substitution. So I can now substitute for log base 3 of 5, 1.465 plus, I can substitute 1.631. And we're going to add those together. That's going to give me 6, 9, 10, carry the 1, so that's 3.096. And that would be the final answer. Now they can get a little bit trickier. Okay, this one's not too tricky, but you may see one, well, we'll see if the next page has one, but there's some little trickier ways to do this. So basically all you're going to do here is take the log base 3 of 5, and you're going to subtract the log base 3 of 6. Well, notice on this one we're actually going to end up with a negative value. So that's 1.465 minus 1.631, and that's going to give us a negative difference. Well, the difference was 1.66, so it's got to be negative 1.66. And there's our answer for that one. Now this one is a little different. We've got 36. Well, that can't be written with 5s and 6s, but we can write it with what? We can rewrite 36 as 6 squared. So we're going to rewrite that. Now what do we know about the power rule? We can then bring this down, so it's 2 times the log base 3 of 6. So now we're going to substitute here for log base 3 of 6. We know this is 1.631. So we're just going to double that times 2. That's all we're doing. So let's multiply that by 2, and that's going to give us 2, 6, 12, carry the 1, 3.262. And that's how you can rewrite those, so that you can get kind of creative rewriting those, okay? And you always want to simplify if you can.